Hi guys, I hope all is well. So today I'm going to talk about the z-score. It's about, so this is in the sections 7.2 and 7.3. So what's a z-score? Z-score Z, that's the number of standard deviations away from the mean for a particular data value. So let me just write it down. So the z-score, it's denoted by z. Okay, so z, the z-score is, z is the number of standard deviations, sigma. Okay, away from the mean, mu. Okay, for, of course, for a particular data value, for particular data value x. Okay, so actually the formula for the z is the following. So z is always equal to x, the variable x, minus the mean over the standard deviation. So this is the z-score. Okay, so let's do an example so you can see what I'm talking about here. So example, let's say we have 6 flowers. Example, say we have 6 flowers. And the variable x, that will be the diameter in inches of the flower. Diameter in inches of the flower. Okay, so we have 6 flowers. So here's my x. So let's say first flower, the diameter is 2. Then let's say 3. Let's say third flower, same diameter. Then fourth flower, diameter is 8. Fifth flower, diameter is 10, and then 10. Okay. So again, x, this number x here represents the diameter in inches of the flower. First flower's the diameter is 2 inches, etc., etc. Okay, so let's say you want to compute the z-score. So what would be the z-score? So remember formula for the z, we said it's x minus mu over sigma, right? So we need here, of course, we need the average, the mean, and the standard deviation. Okay, so well, you can, of course, you can compute the mean. So mu, for example, the average would be, you have 6 flowers, right? So you add the diameter, so it's like 2 plus 3 plus 3 plus 8 plus 10 plus another 10 over, we have 6 flowers, so that's over 6, right? So then mu, for example, in this case would be equal to 6 inches, the average, okay? And then, so we know how to compute the standard deviation, so use the standard formula for the standard deviation. So then let's say the standard deviation sigma is equal to let's say 3.74 inches. Okay, that's the standard deviation, 3.74. Okay, so now if you want to compute the z-score, so here's 2, right? So what will be, so x is equal to 2, the diameter x is equal to 2 inches. So what will be the z-score of 2? So then the z-score would be 2, which is my x, minus the mean. We said the mean is 6 inches, right? Remember, we said the 6 inches, the mean is 6 inches, so that's 2 minus 6 over the sigma, over the standard deviation, so that's over 3.74, okay? So that would be -4, right? -4 over the 3.74, so that would be -1.06, okay? So now, so the z-score, so when x is 2, the z-score is negative 1.06. So now, what's the interpretation of this negative 1.06? Well, that means that this value x equal to 2 is actually 1.06 standard deviation below the mean, okay? So this is 1.06 standard deviation below the mean. So my x, so x is 1.06 standard deviations below the mean, okay? For example, what about 3 here? So if you compute the z-score of 3, so then the z-score of 3 would be, let's say, so x is 3 minus 6 over, again, the 3.74. So that would be actually equal to negative 0.8. So that's the z-score of 3. So negative 0.8, that's the z-score of 3. So that means that x equal to 3 is actually 0.8 sigma below the mean, okay? For example, what would be the z-score of 10? So if x is 10, so then the z-score of 10, that's actually 10 minus 6 over 3.74. So that will be equal to actually positive 1.06, okay? So that means that actually x is 1.06 standard deviation above the mean. Okay, so here, remark guys, so when x is 2, the z-score is negative, right? And when x is 10, the z-score is positive, okay? So in general, if x, so if you compare x to the mean, so if x is less than the mean, okay, then the z-score is gonna be negative. So for example here, x is equal to 2, the mean is 6, so 2 is less than 6, so then the z-score is negative. And if x is larger than the mean, so for example here x is equal to 10, then the z-score is positive, okay? So in general, so when x is less than the mean, the z-score, okay, so if x is less than the mean, the z-score is negative. When x is larger than the mean, then the z-score is positive. And if x is equal to the mean, okay, so if x is equal to the mean, then the z-score z is actually 0. When x is equal to the mean, the z-score z is equal to 0, right? Because I mean, the z-score is supposed to be x minus mu over sigma, right? So if x is equal to the mean, mu, so that's mu minus mu over sigma, okay? So that's 0 over sigma, so that's 0, okay? Now, you may ask, now, why this z-score is so useful? Well, so let me just remind you here, guys. We said when you have, we have a normal distribution, then the shape of the curve would be like, remember we had like, so for normal distribution, so we have, so we said for normal distribution, the curve is bell shaped, right? Here, the highest point is at the mean, right? Here's the mean, okay? Then here, this is mu plus sigma plus the standard deviation. Here, this is mu minus sigma. Here, say this is mu minus 2 sigma, and finally, let's say here it's mu plus 2 sigma. Okay. So now, if you use the corresponding the corresponding function with the z-score. So here I'm using. So here the variable is x, right? Here's my x-axis. Okay, my x. Now, if you use the z-score, so the normal distribution or the normal curve. So the normal curve or function with the z-scores. So now I'm going to use z as variable. Here's z, okay? So, well, and we have actually the same, it's the same curve, okay? And then we said, so if x, remember guys, if we said if x is equal to mu, then z is 0, right? So here, I'm going to have 0. Okay, so this 0 here corresponds to this mu here. So when x is equal to mu, to the mean, then z is 0. Okay, and if x is equal to mu plus sigma, okay, so mu plus sigma, that's one standard deviation away from the mean, right? So then mu plus sigma, if x is equal to mu plus sigma, then z is equal to 1. If x is equal to x plus 2 sigma, so that's 2 standard deviations away from the mean, right? Mu plus 2 sigma, that's 2 standard deviations away from the mean, so then z is equal to 2 here. Here, if x is mu minus sigma, okay, so that's 1 standard deviation below the mean. So that's on the left of 0, of course, that would be -1. And when x is mu minus 2 sigma, so that's 2 standard deviation below the mean. So that's below the mean, so that's -2, okay? And we have the same curve here. Okay, and we still have the same areas, so we still have the same probabilities. So for example, remember guys, we said here from mu minus sigma to mu plus sigma, that would be 68%, right? And from mu minus 2 sigma to mu plus 2 sigma, we said that would be 95%, right? Here for we have the same thing for the normal curve with the z-scores. So from here to here, from -1 to +1. Okay, from -1 to +1, that's 68%. And from -2, from -2 to +2, that's 95%. Okay. Actually, this curve here with the z-score has a name. It's called the standard normal distribution. So this curve here, this is called the standard normal distribution. Okay, so the standard normal distribution, you have the mean or the z here. So you have the 0, the mean equal to 0. Then you have 1, 2, -1, -2, etc. Okay. Well, so still, it's not clear why this is useful. Well, the thing is, this is useful because we can find the area under the curve for any number. So here, if So we have the probabilities or the areas like from -1 to +1. We know that's 68%, right? From -2 to +2, that's 95%. Now the question is, if we have like, let's say here, if you have 1.5, okay, so the question, for example, what would be the area between 1.5 and, let's say here, -1.5, okay? So between 1.5 and -1.5, we don't know yet what's the area, right? We know that the area between -1 and +1, that's 68%, or the probability between -1 and +1 is 68%. Between -2 and +2 is 95%, but we don't know yet what would be the probability or the area between -1.5 and +1.5. So the thing is, with the z-score, we can find the area under the curve for any number z. Okay, so this is so useful because we can find the area under the curve, the area or the probability. Again, the area represents a probability, right? The area under the curve or under the graph for any. So this is really important here. So this is for any number z. Okay, so how do we do that? Well, actually we use the table 3 in the appendix. So I'm gonna post on the CUNY Blackboard this table here. So I'm gonna explain so how does the table work. So but the table gives you actually the area to the left of z. Okay, so the table. So the table in the appendix actually gives you the area to the left of z. Okay, this is really important. So it's to the left, okay, of z. So for example, let me explain how does the table work, because you're gonna need it in the test and in the final. So the table, so you have like, let's say z is -2.93, okay, and you want to find the area to the left okay, this is important. Again, it's to the left of -2.93, okay? So if you check the table, so we have in the first row here, so you have like, if you check the table, again, so you have like, here's z, then you have like then you have like 0.00, then you have like 0.01, then you have like 0.02, okay, 0.03, etc. Okay. Now, in the first column, so we have z, and then we have -3.4, -3.3, etc. Okay, and then at some point we have -2.9. Okay. Actually, the first row represents the value to the nearest hundredth. So this is here, that's the nearest hundredth. Okay, and here, this is the column 1 represents the value to the nearest tenth. So this is the nearest tenth. Okay, so here, like here in my example, right? So we have 2.93, right? So the nearest tenth is, so here the nearest tenth is negative 2.9, right? So here is my negative 2.9, okay? And then the nearest hundredth is 3. So here, the nearest hundredth, it's actually 3, right? And as I said, for the tenth, so it's actually 9, negative 2.9. So the tenth here. Okay, so what you do, so the nearest tenth is, so it's negative 2.9 here, and the nearest hundredth is 3, right? So what you do, you take the value which is here. So this is my negative 2.9, right? And then this is my nearest hundredth, which is 3, right? So you take this value here. So this value here, which is, if you check the table, it's actually 0. And then 0.0017. Okay. So this is, actually the area to the left of negative 2.93. Okay. So here, be careful, guys. In the first page, so the values of z are negative. If you wanna, for positive values of z, you need to check the second page, right? So be careful of the sign here. So in the first page, the z is negative. If you check the second page, the z is positive. Okay. So here, what I'm saying is that so this area to the left of negative 2.93 is 0.0017. So that means that the probability that z is less than negative 2.93 is equal. So that means, so the probability that z is less, okay, than negative 2.93 is equal 0.0017. Okay, so again, guys, here be careful. So when it's less, so z is less than negative 293, less means to the left. It's to the left of negative 2.93. Okay, so for example, now what would be the probability that z is larger than negative 2.3? So larger means to the right of negative. So here, this is larger. So larger means to the right. To the right of negative 2.93, okay? So what I'm saying, guys, is, so, you know, you have, here's your function or your curve. So here somewhere you have, let's say here, this is negative 2.3, okay? So less means to the left. Okay, so less means to the left, so that will be this region here. So this region, this is the left, or less. Okay, it's to the left of negative 2.93 or less than negative 2.93, okay? Now, larger than negative 2.3, that's to the right, so that will be this area here, this one here. Okay, so this is to the right to the right of negative 2.3 or larger than negative 2.3. Okay. Now, so what would be this probability that z is larger than negative 2.3? Well, that would be equal to actually, because remember guys, the total area is equal to 1. So the area to the right is going to be equal to 1 minus the area to the left, right? Because again, the total area is 1. So the area to the right is 1 minus the area to the left, which is z less. Okay, so that will be equal to 1 minus the 0.0017. So that's equal to 0.9983. Okay. Now, if you want to find the probability between two numbers, so for example, here's again my curve. Okay, so let's say here this is negative 2.93, and here let's say 0.91. Okay, and the question is, what's the probability that z is between? So it's larger than negative 2.93 and less than the 0.91. Okay, so what that would be this area here, this one here. So this is z between the negative 2.93 and positive 91, okay, 0.91. So how do we compute such area? Well, the idea is very simple. So what we do, okay, so you take, so here is, let's say, here, okay, let's say this is 0.91, right? So what you do, you take the area to the left of 0.91. Okay, this is the whole area to the left of 0.91, and what you do, you subtract the area to the left of, so here's negative 2.93, right? So you subtract the area to the left of negative 2.3, so what's left is the area between. So what's left is this area between negative 2.93 and 0.91. So what I'm saying is, so this probability here that z is between negative 2.93 and 0.91 is actually the area to the left of 0.91 minus, and then you subtract, you remove the area which is to the left of a negative 2.93. Okay, now what's this area here to the left of 0.91? So we have to use the table. So be careful here, this is positive, right? So you need to use the values in the second page for positive. Okay, this is very important, guys. Make sure that you're using the right page. First page is for negative z's, and the second page is for positive z's, okay? So for 0.91, if you check the table, that would be 0.8186 minus, so to the left of negative 2.93, we said it's 0.0017, so the answer would be 0.8169, okay? Or if you prefer, that's 81.69%. Okay, now, so how do we apply this in the real world? So here, let me give you a couple of examples, okay? Example 1. Okay, so example 1, well, so what we do in general, well, we convert, so in, so let me just first erase the examples. So what we do in general, so we So in general, okay, so what we do is we convert x to z, and then use the table to find the probability. The probability. So for example, let's take an example. Let's say the example here. So let's say the functional life of Blu-ray players follows normal distribution. Okay, so x, that's the functional life of Blu-ray players. Okay, and it follows normal distribution. This is important. So we have a normal distribution here. It follows a normal distribution. Okay, with normal distribution with average or mean. Distribution with average mu equal to 2. So the mean is 2.3 years, and the standard deviation sigma is 0.4 years. So the question here, what's the probability that a Blu-ray player will break down during the guarantee period of 2 years? So the Blu-ray player will break down after or during the guarantee period of 2 years, during 2 years. Okay. So there are 2 steps. So solution here. So again, x, that's the life, represents the life of the Blu-ray, right? That's the life of the Blu-ray player. Okay, and you want to find the probability that the Blu-ray player will break down during 2 years, right? So you want to find the probability that x is less or equal to 2 years, right? 2 years. So what we do, step 1, as I said, we convert x to z. Convert x to z. So what will be z in this case? Remember, guys, the formula. So z, we said z is equal to x minus mu over sigma, right? So here my x is 2, right? This my x here is, so here we're x is 2, so this is 2 minus mu, the mean, that's 2.3 years, over the standard deviation, the sigma, which is 0.4 year. Okay, so that will be equal to actually negative 0.75. Okay, that's the corresponding z-score. Okay, now we want the probability, right? So step 2. So we want the probability that x is less than 2. This is the same as probability that, because the corresponding z is negative 0. So x is 2, the corresponding z is negative 0.75. So that's z less or equal to negative 0.75. Okay. So that would be equal to, well, so now we check the table. So here z is less, right? Z is less than negative 0.75, so that will be the area to the left of. So left left of negative 0.75. So if you check the table, so for negative 0.75, that would be 0.266. Okay, or in other words, that's 22.66%. So here what I'm saying is that the probability that the blue player will break down during the guarantee period of 2 years is actually 22%. Okay, so that's how we use, the table and the z-score to find probabilities. Okay, another kind of another example. So another example 2. Example 2 is kind of different of the previous example. So in this example number 2, we know the probability. So here we have the probability. Okay, but we need to actually find the corresponding x, and we want to find the corresponding x. So let's do an numerical example here, corresponding x. Okay. So how does it work? So here's an example. So question, let's say, find, let's say, the z value says that the probability or the area, so the probability or the area to the right of z is 3%. Okay. Well, so probability to the right of z. Okay, so so step 1, you wanna use the table, right? But to use the table, the table gives you the area to the left, all right? But here we know that the area to the right of z is 3. Okay, so what's the area to the left? In this case, the area to the left. So that will be equal to 1 minus the area to the right. So 1 minus 3%. Okay, or 1 minus 0.03. So that will be 0.97. Okay, or 97%. Okay, so 0.97. Okay, so you know that the area to the left of z is 0.97. Now, step 2, we want to find the z value, the corresponding z value. So we have to look to the table. So let's look to the table. So here's step 2. So if you look to the table and you see where is the 0.97? So here the area is equal to 0.97. It's not the z here, right? Where the area is equal to, where the area to the left, of course, is where the area to the left is equal to 0.97. Okay, so here's your table. So again, here's your z, right? So you have here 0.00, 0.01, etc. And then you have 0.08, and then you have here 0.09. And here, if you look to the values of z, somewhere here, let's say you have 1.8. Okay, and here you're gonna have in the column of 0.08, you have 0.96. So we have 0.9699, and here you have 0.9706. Okay, so here again, guys, this number here, so this is in the second page. Okay, this is second page, page 2. Okay, because this is a positive 1.8, right? So if this number here, these numbers here, they represent the area, right? This is the area. Here are the values of z here. Okay, so where the area is equal to the left is equal to 0.97. Well, here you have 0.9699 and 0.9706, right? So which number is closest to the 0.97? Well, the 0.9699, it's closer to the 0.97 than the 9706, right? Because the difference here between 9699 and 0.97 is 0.0001, and here the difference between 9706 and 97 is 0.006. Okay, so this number here, this is the closest number to 97. So closest number to 0.97, right? Okay, so what would be the corresponding z? Well, the corresponding z would be, so here z, here it's 1.8, and here nearest hundredth it's 0.08, right? So then z is actually equal to, so z is then 1.88. Okay, because we have 1.8 here and the nearest hundredth here is 0.8, so then z is 1.88. Okay, so 1.88, right? So okay, now let's see. Now suppose that suppose the time to complete the test follows a normal distribution. Okay, with, let's say, average mu is 40 minutes, and standard deviation sigma is 5 minutes. Okay, so the question is, after how many minutes can we expect all but 3% of tests to be completed? Okay, after how many minutes can we expect all but 3% of tests to be completed? Can we expect all but 3% of the tests to be completed? Okay, so here to be completed. So here the probability is. So the probability here is, so we have 3%, right? So the probability that here the probability is equal to 3%. Okay. So what would be the corresponding? So probability is 3%, right? So what would be the corresponding z? So we said here z is 1.88, right? That's what we said in the previous question, right? So all but 3% of the test to be completed, right? So some probability that the test is not completed here. So it's actually 90. The probability that the test is completed is 97, and there's only 3% not completed, right? So that's the 3%. That's to the right of the z. So the corresponding z is 1.88. Now, what's x in this case? So what's the time x? So time x is equal to, well, actually, because we have this formula, remember, guys, so we said, z is equal to x minus mu over sigma, right? Then x is actually equal to sigma z plus mu. Okay, and actually this is called the raw score. This one here, the raw score. So x is equal to sigma z plus mu. Okay, so that's equal to, so sigma, what's sigma? Sigma is, we said it's 5, right? So it's 5 minutes, right? Here's sigma. Okay, times z, we said the corresponding z here is 1. So times, so 5 times 1.88. Okay, that's the z, right? Here's my z, corresponding z, plus mu. It's given in the problem, so mu, the average is 40 minutes, right? So plus 40. So that will be equal to, so then x is equal to, again, so it's 5 times 1.88 plus 40, so that's 49.4 minutes. Okay, so we expect all the tests but 3% of tests to be completed after 49.4 minutes. After 49.4 minutes. Okay, so that's the answer. Okay, guys, I guess I'm gonna stop here, and you can find more examples and more details in the lecture notes. See you. Thanks.